members, we are back with A-level biology, and today our emphasis is going to be put on what we call synaptic transmission. And if you don't call it synaptic transmission, we can also say transmission across the what? The synapse. Remember, the synapse is going to be simply the junction between a neuron and what? A neuron. If now we are going to make a flashback, if, for example, information is going to move from the foot to the, for example, the brain, the head, the information must pass via numerous nerves. Thousands and thousands of what? Nerves. Now, how does the information or the impulse or the action potential move from a nerve to a nerve? That is by jumping a junction between a nerve and a nerve. And that junction, this junction here, between a nerve and a nerve is what we can say, what we can call a what? A synapse. So now, members, the following terms are very, very vital as we are dealing with what we call synaptic transmission. We need to know properly what we call a synapse. We are saying this is a synapse. We are considering a nerve up, which we are calling presynaptic neuron or nerve, and a nerve down, which we are calling postsynaptic what? Neuron or nerve. Now, when you combine, when you bring now the upper one and the downer one, now the gap between them is what we are going to call a synapse. Now, the synaptic rift, now this one is going to be this space now here. All of this space here. This space now inside the junction is what we are calling synaptic what? Rift. Then it's presynaptic nerve. That is the nerve up here. The one which we are reflecting here. That is the presynaptic neuron or nerve. Then postsynaptic neuron or nerve. That is the downer one, where the action potential is going or where the impulse is going. So presynaptic, postsynaptic. Then the neurotransmitter substance, we can see that the information is going to move from this one, this nerve, to this one. The movement of the information from this nerve to this nerve is going to be carried by a chemical substance, which we are calling the neurotransmitter substances. The common neurotransmitter substances, we have what we call acetyl what? Choline. This one we are going to see it, especially in the synapse, which we are calling the cholinergic what? Synapse. Then we have another known as noradrenaline. This one we are going to see it in the synapse, which we are calling adrenergic what? Synapse. So these ones are commonly, and we are going to base more on those neurotransmitter what? Substances. Members, also we need to know what we call the gated channels. In this transmission, we are going to rely more on the gated channel or the voltage channels. One of them is going to be calcium channels. Opening of this one, we are going to see entrance or the influx of calcium ions. Then the opening of the sodium channels, we are going to see the influx of the sodium what? Ions. The transmission which we are going to look at across the synapse, we are going to look at how the action potential moves from the presynaptic neuron here downwards to what we are calling the postsynaptic what? Neuron. How it is jumping in this gap here is what we are going to call the synaptic what? Transmission. However, all of these components which we have talked about, they are going to be involved here. Now, to get a clear image of how the information is moving from presynaptic neuron to the postsynaptic neuron, or the action potential, the impulse, let us try to look at what we call the mechanism. Details of the mechanism. One, we are going to begin by the arrival of the impulse. Arrival of the impulse. The impulse is arriving where? The impulse is arriving here now. The impulse is arriving at the presynaptic what? Neuron. So arrival of the impulse at the presynaptic what? Neuron. The arrival of the impulse brings what? We are going to see number 2, that the voltage of the postsynaptic neuron changes. Now, we are seeing that because of the arrival of the action potential action potential here, or what we are calling the what? The impulse. You can as well call it the what? The impulse here, that the voltage of the synaptic neuron changes. What do we see, number 3? We see that the calcium channels, these are channels along which calcium passes. The calcium ion channels open. When the calcium channels open, or calcium ion channels open, what do we see? The calcium influx. Calcium ions influx into the pre-synaptic neuron, the upper one. Now, we are seeing now calcium ions influxing here. They enter in simple terms from the cleft. So we see calcium ions here, many of them entering here, like that. Causes what? It causes the synaptic vesicle. Remember, these ones are carrying neurotransmitter substance to move towards the pre-synaptic what? Pre-synaptic membrane. What is the presynaptic membrane? We are going to see these ones moving downwards. These ones, remember, they are the synaptic what? Vesicles. Once now they move here, they are going to do what? After the synaptic vesicles moving towards the presynaptic membrane, we see number 6, they release synaptic vesicle, release the neurotransmitter, this is the neurotransmitter substance. Remember our neurotransmitter substance, we said we have 2, we can use acetylcholine, or we can even use noradrenaline. And we said those ones using acetylcholine, we are calling them the cholinergic synapse, and those ones using noradrenaline, we are calling them adrenergic synapse. Now, when they release the neurotransmitter substance, what happens next? Now, releasing it means you can decide this point here that now there is some, you can see some release here. These ones which I'm representing here. It means the chemical is powering in the cleft here. Shall we see the chemical powering in the cleft? Now, after the neurotransmitter substance being released in the cleft, it moves. The neurotransmitter saying, the neurotransmitter substance, remember we said it can be acetylcholine, or it can even be adrenaline or noradrenaline. Neurotransmitter substance now move towards what? The postsynaptic membrane. And when it reaches there, we are going to see that the neurotransmitter substance, now binds with the receptor, the postsynaptic receptors, binds with the postsynaptic receptors. Remember at this point we said receptors of 2 types. We have receptors which can be, at that point, receptors can be inhibitory receptors. These ones are going to do what we call inhibition. That one now, it means the impulse will not move downwards. Then we have those receptors which are called excitatory receptors. So the excitatory receptors, these ones now are going to help us to do what we call excitation. If there is excitation, we are going to see depolarization, and there the impulse is going to move downwards. Now, at that point, to understand properly whether the impulse moves downwards or doesn't move. If it is going to move downwards, the postsynaptic neuron, there must be excitation. If it's not going to move downwards, there must be what we call inhibition. Inhibition. Now, the image of whether there is excitation or inhibition is going to be based on this biology. We need to understand what we are calling excitation as well as inhibition. Because the movement of the action potential, which we are going to talk about, or the impulse, is basing more on whether there is excitation taking place or whether there is inhibition taking place. So, to understand properly the concept, we need to clearly talk about excitation and inhibition. But you have to put into consideration that when I talk about excitation, I'm going to base more on what you call excitatory receptors. Then when I talk about inhibition, I'm going to base more on inhibitory receptors. How are we going to see this one acting? Excitation will take place. I want you to grasp this one properly. We are going to see excitation taking place. We are going to see one. The following are going to occur, but one is going to be the opening of the sodium The sodium channel. Excitation, which I'm referring to, will involve all the following events. The first event, opening of the sodium channels. When the sodium channels open, members, we are going to see that the sodium ions will now, influx in the what? In the neuron. Flux in the neuron. If, for instance, I'm going to take this example here, naturally we are seeing that inside the nerve or the neuron, we have a lot of potassium ions and more negative ions inside from the organic what? The organic salts. Now, for excitation to take place, we are going to see that the sodium gates here always open. When they open, you are going to see sodium. If I'm going to put that one to be like sodium, like that, you are going to see now that more sodium is going to enter here. You shall see more sodium entering. More sodium is entering. When more sodium enters inside, what are we going to see? Inside, we are going to see that more positives are going to accumulate inside. Remember, you have the potassium ions inside, and then you are adding sodium ions as a result of the opening of the sodium channels. Now, what are we going to see? The overall potential inside is going to become more what? More positive. Now, at the same time as the sodium ions are entering in, we are looking at the way how we can generate excitation. We see that there is depressed conduction or conductance. And what causes this one? We see it in two ways. One, we see that if excitation takes place, we are saying there is generation of what we call excitatory postsynaptic potential, which is going to help our action potential to continue moving downwards. How does excitation take place? Excitation is going to take place if we have what we call excitatory receptors at the point of the postsynaptic what? Membrane. If we have excitatory receptors at the postsynaptic membrane, the following is going to occur. One, as the neurotransmitter substance combine with excitatory receptors, we are going to see that the sodium ion channels, these are voltage channels, open. When they open, what are we going to see? The sodium ions influx in the postsynaptic what? Neuron. When they influx in, now we are going to start this point, assuming this is the neuron, assuming this is postsynaptic neuron, we are going to see now sodium channels opening, and we see a lot of sodium ions, which are outside naturally entering in. Sodium ions are going to enter a lot. When the sodium ions enter inside, we are going to see the inside part of the postsynaptic neuron is going to become more positive. Once they become more positive, the magnitude of the positive, when it increases, we see that now depolarization is going to take what? Place. Depolarization takes place. Once depolarization has taken place, and it can reach threshold value, take note of the threshold value. If excitation is big enough to reach what we call the threshold. Remember we talked about what we call threshold value. This implies now we are going to generate what we call an action potential. And that action potential which we are talking about is going to be reflected by what we call excitatory postsynaptic what? Potential. Excitatory postsynaptic what? Synaptic potential. And that one now implies our impulse is going to move downwards to the postsynaptic what? Neuron. Now that same mechanism boosted by what we are calling depressed conduction. Depressed conduction, here we are going to see that the chloride ion channels cross. When they cross, we see no more chloride ions entering here. Remember, when the chloride ions enter here, what are you going to see? You will be reducing the positive. So what happens is the chloride channels now cross. When they cross, no chloride ions enters. This means inside will remain with the big positive. Because the chlorides, once they enter here, once you see chlorides entering here, you are going to be with the big negative inside. And there will be what we are calling polarization or hyperpolarization, which will not now lead us to what we call excitation. On top of that, there is now closure of what we call the potassium ion channels. When the potassium ion channels close, it implies that no potassium ions are moving out. Remember, naturally, we have potassium ions here inside the neuron. Now, the potassium ions can move outside. But once now you close the potassium ion channels, it means no potassium ions are moving out. And when no potassium ions are moving out, you are making the inside part of the postsynaptic neuron to be with a bigger positive. And then at the end of the day, we see a bigger repolarization, which is going to reach a threshold value to give us an action potential. The excitatory postsynaptic potential being generated. When we come back here, that one we shall see that our impulse or our action potential move downwards from presynaptic to postsynaptic. That is as a result of excitation. Which excitation we have said is as a result of the opening of the sodium channels to allow in more sodium inside. That is if we have what we call excitatory receptors. 2, when there is a depressed conduction, that is by not allowing chloride ions inside and not allowing potassium ions what? Outside, to increase the magnitude of the positive charge inside. And 3, there are changes in the metabolism inside the postsynaptic what? Neuron. These changes are going now to result into what we call the reduction in the inhibitory receptors, at the same time increase in the excitatory receptors. So when you reduce now inhibitory receptors and increase excitatory receptors, this one you are going to generate a bigger depolarization. So the 3 are important: opening of sodium channels, depressed conductivity or conduction, then various changes in internal metabolism. Assuming we have what we call inhibitory receptors, these ones here. When you have inhibitory receptors, it means we are going to do what we call inhibition. The impulse here, the action potential, is not going to cross. How does that one occur? We are going to observe that the chloride ion channels are going to open if the receptors are inhibitory. When the chloride channels open, we are going to see more chloride ions are going to influx in. Assuming this is a postsynaptic membrane of the now the postsynaptic neuron, we see now chloride ions, many. They are entering in. When the chloride ions are entering in, we are going to see now a bigger negative inside because of the entrance of the chloride out of the neuron. So, on the other side, we say no potassiums are moving out, but here now, we are going to see again, more potassiums are going to move what? Out. Potassium ions are moving out. More chloride ions are going to influx what? In. And then we are seeing inside is going to become more negative. At the same time, more potassium ions are going to move what? Outside. To reduce the positive inside. Then it implies that you are increasing more negative inside. And this one, the overall effect is going to be that the neuron experiences what we call hyperpolarization. Because of hyperpolarization now, we don't see depolarization. If there is hyperpolarization, it means there will be no depolarization. And once there is no depolarization, it means there is no way how the action potential can move downwards there. In addition to that, we are seeing that even there is changes in the metabolism of the postsynaptic what? Neuron, of the postsynaptic neuron, as a result of now the activation of the receptor enzymes. Now this one also is going to add on what we are calling inhibition. So when you bring the opening of chloride ions and then the increase in the conductance of potassium ions, as well as activation of the receptor enzymes, you will end up now having what we call hyperpolarization. And if there is hyperpolarization, we are going to inhibitory postsynaptic potential. And this one cannot allow the action potential to move downwards. Remember, we are saying here that the action potential must move from polysynaptic cell, now to what? To postsynaptic. But who can favor the movement? That is excitation. Now what have we observed there? We have observed inhibition. If there is inhibition, it means the action potential cannot be generated. At this point, at the inhibitory postsynaptic potential being generated, we don't see an action potential being what? Being generated. And if there is action potential, it means there is no flow of the impulse downward.